So hello guys, in this video we are gonna see about Biot savart law, that is known as BS law. In this video we are gonna see about how the Biot savart law came, what's the theory behind it, and the derivation of the formula of Biot savart law obviously, and special cases, that is Biot savart law, the magnetic field in the center of the ring due to the ring is current carrying conductor, and the magnetic field in the axial point of the ring, that will be discussed in this video, and how to apply it, that is numericals about Biot savart law. So let's dive into the video. First we will see how it came. At the starting of the story, there is one current carrying wire, that is CC wire, that is current carrying wire. So in this wire there is a steady current flowing in it, and at here a point P is there. The distance from the current carrying conductor and point P is R, and this is dl, that is a small length of the wire that is in the distance r from the point P, and this is the angle theta, and here theta is angle between the CC wire and the line joining it. So this is the basic diagram of Biot savart law. Then we will see the same diagram. Here theta, this is r, this is point P, the current I is flowing, and this is the small current element, length element. So we will be calculating dB. So small dB is directly proportional to I. What is I? I is the current flowing in the conductor. So dB is directly proportional to dl. What is dl? D is a small length element of the current carrying wire. So then what is dB is directly proportional to theta. What is theta? I have already told you. Then dB is inversely proportional to r square. This is what's the basics of the Biot savart law. Then we will see the derivation of BS law, that is dB directly proportional to I dl sine theta by r square. This we know how it came. Then to remove this proportionality constant, this proportionality symbol, we will include a constant k. I will be telling what is k in a while, in a moment. Just wait. By r square. So k is a constant, that is mu naught by 4 pi. Like we had k in the electricity chapter, the what do we say, the first and second and third chapter of the 12th CBSE NCERT physics, that we had 1 by 4 pi epsilon naught, that is 9 into 10 to the power minus 9. We had this constant. In this chapter we have this constant value as 10 to the power minus 7. So the final equation of Biot savart law will be mu naught by 4 pi into I dl sine theta by r square. Guys, note it down. This is the equation for Biot savart law. Then we will be writing the vector form of PS law, that is dB vector equal to mu naught by 4 pi. I is a scalar quantity, so it will be out, and dl vector into r vector. We are multiplying this equation by r. So to balance it out, here we have square. So multiplying and dividing r on numerator and denominator, so we will be getting r cube. So this is the vector form of Biot-Savart law. So what we saw? We saw the formula KIDL sine theta by r square. It's the formula for Biot-Savart law. So we have known what's the derivation. Next we will be discussing some special cases which are used in calculating I will be mentioning as CLC. So in calculating magnetic field in circular CC loop. So it's the first special case. I will be discussing the diagram. That is, imagine there is a circle which is a current carrying wire. So at the center we have our point P and the current flowing is I, and at this radius, so we will be mentioning it as R, and this is dl. I will be explaining. Wait, we have one circle, one point P, current I, radius R, small element of the circle. This is a basic diagram. We are discussing special case number 1. So this is the diagram. So we have our Biot-Savart law, that is K into IDL by r square. Here we don't write sine theta because it's a circle and circle has no theta value, so we are not writing sine theta. Otherwise, what is theta? Theta is the angle between the line joining the current carrying wire and the point P. So here theta is 90 degree. So sine 90 is 1, so we won't be including that sine theta in this equation. So we are going to integrate it. So dB equal to integration of KIDL by r square. So here we will be getting dB. So K is constant, current inside the wire is constant because it's the steady current, and by r square. So radius of the circle is not going to change, so it is constant. The only thing we are going to integrate is dl. So what we will be getting at B equal to Ki by r square. What is integration of dl? That is L. What is L? L is the length of the current carrying loop. So L equal to 2 pi r, that is the circumference of the circle. So I will be writing here B equal to mu naught by 4 pi I by r square into 2 pi r. So this r and r square will be getting cancelled. So this 2 pi and 4 pi will be getting cancelled. So we have 2 pi in the denominator. So the final equation is B equal to mu naught I by 2 pi r. This is the magnetic field of the current of this point due to current carrying conductor. This is the equation, and I will be discussing some numericals based on this in the last part of the video. We will be discussing the second special case of Biot-Savart law. That is, I will be first drawing the diagram. First I will be explaining the diagram, then I will do the derivation. Wait a minute guys. So this is the radius r, and this is the distance x, and here the hypotenuse side will be root over, so we will be mentioning this as r square plus x square. Here we are taking dl. So guys, this is the basic diagram of the second special case, that is the current carrying loop has a point axial to it. The point is in axis with the current carrying loop. In previous case we had the point P in the center, and now it is at the axis. We are taking dl here, so the hypotenuse side will be r equal to root over r square plus x square. So this is okay. Then we will be writing it as, first I'll explain the full diagram to you. Wait guys, I'll explain the full diagram. This is hypotenuse, this is radius, and we will be having dl here. So you will be asking why we are only taking dl at this side. To explain it, I will be taking dl in both sides, so it will be like this. Okay, so magnetic field due to this current carrying conductor will be like this, dB, and magnetic field due to this current carrying conductor will be like this. If we resolve this vector, will be getting as dB, we will be getting as dB sin theta for this vector, and for this vector also we will be getting as dB sin theta, and for the cos theta we will be getting as dB cos theta and dB cos theta. So this dB cos theta and this dB cos theta will be cancelled out because they are equivalent and opposite to each other. So we will be only considering this dB sin theta. So what is B net? That is dB sin theta. The net magnetic field, I will be drawing a small diagram here so that you can always take a reference. Here point P, here distance is x, here r, and this hypotenuse distance is root over x square plus r square. So it will be very helpful to you. The net magnetic field on this point due to this dl and this dl is what guys? dB sin theta. So if we integrate this equation, what is dB guys? dB is actually ki dl sin theta by r square. So we will be getting as integral ki dl sin theta by r square. So this is the integration formula, and we know that, wait, the small diagram for your reference I will be writing. This is the diagram. So B net equal to Ki dl. dl is 2 pi r as we know. We will be getting this equation. Then if we split it, here r square, r is root over r plus x square. So here sin theta is, what is sin theta? Adjacent by hypotenuse. What is adjacent in this diagram? It is the adjacent side. So adjacent by hypotenuse is this one. So root over r square plus x square. So here we are getting it r square plus x square the whole square. So this is that, and then we are getting it r by root over r square plus x square. Then what are we getting, guys? Into 2 pi r, I missed, sorry guys, this 2 pi r, okay. Then k into I into 2 pi, this is capital R. So this r and this r will be multiplied, so by r square, and this is, I will be writing here, 1 by 2 the whole square into 1 by 2. What is this? 1 by 4 into 1 by 2. What is there? 3 by 2. So here whole power 3 by 2. If we expand this, mu naught by 4 pi into I into 2 pi r square by root over r square plus x square whole power 3 by 2. This 2 pi will cancel, so here 2. Then the final equation of p equal to mu naught by 4 pi into I r square by, it's not 4 pi, sorry, 2 into root over r square plus x square whole power 3 by 2. So this is the final equation for the special case number 2. Okay guys, see the derivation, and then we will be solving some questions. The questions will be like this: there is a current carrying wire of radius 2 meter and the current flowing to here is 2 amps. Find the magnetic field at the center of the wire. So we'll be using the formula B equal to mu naught I by 2 pi r, that is mu naught into 2 by 2 pi into 2 will be getting mu naught by 2 pi, so that 2 is getting cancelled. So b equal to mu naught by 2 pi, that is, if we expand 2 pi, that is 2 into 3.14, that is 28 we have mu naught by 6.28. We have our answer like this. The questions will be asked. So that's it for today's video. In next video we will be discussing Ampere circuital law. So bye guys, I hope you like this video. If you want to solve some questions, take this question. There is a current carrying loop at the distance. What is the distance, guys? Distance is 5 meter. The radius is 2 meter. Find the note down this question. Find the magnetic field at point P due to current carrying loop. Take this question as homework and solve it and comment down the answer. So this is the Biot savart law, guys. We will be discussing the Ampere circuital law in the next video. Thank you. Take care.